Hey guys, today I'll be explaining the physics video, the physics quiz for week 9 CA. Okay. Again, this is same as last week, only with a few new questions. Okay. So I'm sure all of you already know these questions from last week's exam, but I'll go over them anyway. All right. From question 1, two bodies P and Q form a system. After some interactions, Q has lost 80 joules and P has gained 60 joules. Which statements are true? Okay. Let me showcase this to you guys. Okay. So imagine a system, okay? Oh wait, never mind. Q has lost 80 joules and P has gained 60 joules. Okay. Not an isolated system, sorry. So yeah, non-isolated. Okay. So since this is non-isolated, Q has lost 80 but P has gained 60. So where's the other 20 that P was supposed to gain? It left the system. So that means it's not isolated. So we can say the system has lost 20 joules. And we can say the system has gained negative 20 joules, which basically means it lost 20 joules. It's the same meaning. It's just they're just trying to trick you. Now for the last one, body Q has gained negative 80 joules. Since it lost 80 joules, it's gained the negative 80. So again, same thing. They're trying to trick you. But they all have the same meaning. Okay? For question 2. Two bodies, P and Q, form an isolated system. Which statements are true? Okay, now that you have an isolated system, let me explain it. Let me showcase it properly to you guys. Now imagine a square. Okay, we're gonna call this the isolated system. Okay, now we have body P and Q. We have P here, it's like a ball, and Q here, it's also like a ball. Okay, they form an isolated system. Which statements are true? Okay, now energy gained by P equals the negative energy lost by P. Okay. They're saying here that the energy gained by P, so plus P, is equal to the negative of the energy lost by P, so minus P. And negative make positive. So they're basically equal, they're the same thing. It basically means negative energy lost by body P is the same as energy gained by body P. So this is correct. Okay. Now energy gained by P plus energy gained by Q equals 0. Now let me give you some numbers, okay? This is just an example. It's not numbers you have to memorize. I'm gonna say 50 joules. Let's say body P has 50 joules, right? 50 joules. Now it loses 50 joules, and body Q immediately gains 50 joules. This is conserving energy. In an isolated system, what does isolated system mean? That no energy from outside or inside is leaves or enters. Okay, so the energy inside stays constant. It's not gonna be more than 50 or less than that. Okay, so once they interact, P loses 50 joules and Q gains 50 joules. Okay, Q gains exactly what body P lost. So that's what isolated system means. So now, as we were saying, energy gained by P plus energy gained by Q equals 0. So since let's again, we're taking the numbers for example, they're just examples. Negative 50 plus 50. What is that equal to? 0. So energy gained by P plus energy gained by Q, P gained negative 50 and Q gained 50. So when you add them up, it becomes 0. So then it's always 0. Okay. Now the last one, energy lost by P plus energy lost by Q equals 0. It's the same as this one. It's just this time instead of gaining, it's losing. That's it. So it's like what's it called? In our case here, energy lost by P is basically 50 joules. Energy lost by Q is negative 50 joules. Okay, it lost negative 50, so it means it gained it. Okay, so again, you add them up, it becomes 0. So same thing, loses or gains. Both of them gaining equals 0. Both of them losing equals 0. That's it. Now for question 3, now this is easy. The figure below shows two different positions, A and A and B of a falling football. At position A, the energy possessed by the football is 100 joules, while at position B, the energy possessed by the football is 75 joules. So fill in the blank. The amount of energy lost by the football between positions A and B is what? This is very simple. It's simple math. At this point, it had 100 joules, okay? Then it fell and lost an amount of joules, an amount of energy. It became 75. So what's 100 minus 75? 100 minus 75 is 25. So here, the energy in that process lost is 25 joules. And the unit is 25. That's it. All easy questions. See, they're all like last week. In an isolated system made of two interacting bodies, A and B, energy gained by A plus energy gained by B is equal to 0. Alright, so like the question we did in number 2, like I said, gained by A, gained by B is equal to 0. Lost by A, lost by B equal to 0. They're basically whatever they gain, they're opposite to each other. So that means negative and positive add them up, it becomes 0. Okay, and remember it's an isolated system, so both numbers are the same. Now, energy is being transferred between two interacting objects, A and B, in a closed system. Object A loses 30 joules of energy. The amount of energy gained by object B is 30 joules. Okay. Yeah, same thing. A closed system or isolated system. Object A loses 30 joules of energy. So what does object B gain? It gains 30 joules. Since they interact, the energy is conserved, energy basically transferred. Object A loses the entirety of 30 joules, and object B gains all the energy. So that's basically it. So object A basically gained negative 30, object B gained 30. And for question 6, energy can be transferred from one object into another when a force moves the object through a distance. That's simple physics. Yeah, that's it. Since what's it called? When you have like two objects, okay, and let's say a force is acting on it, right? Like the energy is transferred through a distance, of course, right? That's how. When a force acts on it, the energy is conserved through. The energy moves to another object through the distance. Just a rule you have to know. Underline the name given to the energy transferred by a force along a distance. Work. Okay, work. Since what's it called? Work, force along a distance. Work is equal to force times distance. Which reminds me, in the previous question, it's basically the same thing. Work equals force times distance. Work is like energy transferred. Okay, so yeah, that's basically it. You got two objects. The force you multiply it by the distance. That's the energy transferred, and that's work. Now let's test work. A man pushes a car by exerting a force of 100 newtons on it. He pushes the car for a distance of 10 meters. Okay, so like we said, they're asking now for the work done by the man on the car. Okay, so like we said, the work is equal to force times distance. Force is 100 here, 100 newtons, times meters, the distance, which is 10. 100 times 10 is 1000 joules. Remember, work is always measured in joules, or J. Okay? How ironic. Okay, underline the unit that is used to express work. Okay, joule. Guys, just a quick reminder. In the exam, if they ask you the unit, write joule, okay? Because last week I did a mistake and I wrote J. I put J instead of joule. And that was the only mistake I made. So don't do that. When they ask you for unit, put joule, always. But if they ask you for the symbol, write J, okay? But every time they ask you for unit, it's joule. Right, like the entire word. Now, this question came last week. A 0.1 kilogram box lifted from the ground and placed on a shelf at a height h as shown below. Assume g, the gravitational acceleration, equals 10 meters per second squared. If the work done on the box is 1 joules, they gave us the work already. Then the height h is equal to, okay. Now, I'm gonna introduce you to a rule. If you didn't already know, the potential energy equals mgh, okay? Mass times gravitational acceleration times height. So now let's apply it here. Now you apply this rule whenever you see the height or it's lifted up from the ground. You know that you have to use mgh. Basically, a work acted on by gravity. 0.1 is the mass times the gravitational acceleration is 10 times h equals the potential, the joules, the energy, which is 1, which they were 1 minute. Oops, sorry. 1 joule, which they already gave us. So you put it equal to 1. So 0.1 times 10 is 1 times h is just h. H equals to 1. So we have the height as 1. That's it. So again, you multiply 0.1 times 10. The decimal moves 1 point, so it becomes 1. So now you got rid of these two. You have 1 times h equals 1. You do 1 times h is just h, and equals 1 to stay the same. So h is equal to 1. The height is equal to 1 meter. That's it. Now, select the cases in which the body is gaining energy. Okay. Let me just explain something really quickly. Here, when they say gaining energy, they're asking for motive. Okay, and basically means the force moves the same in the same direction as the direction of motion. So as we can see here, the arrow moves here, and force moves here. So the same direction. So since it's like motive, it's moving along the direction. It's not resisting. Okay, so when it's moving along, it's gaining energy. Like how you push a cart, for example, on a smooth floor. A cart. Okay, you push a cart along a smooth floor. Okay, it will keep moving faster and faster. And that point, it's gaining energy until it slowly slows down. Okay. Now, so that's it. The cart moving along a smooth floor, or like basically not resisting. The forces are not resisting the cart, like not pushing it backwards. Then it's motive. So that's it. When the force moves the same direction as the direction of motion, it's motive. It's moving to the positive direction, basically. Now, when it's negative, when it's resistive, it's going to be opposite direction, like here. This is resistive motion. So it's resistive work. Okay, it's moving in opposite directions. Remember that. Whenever it's opposite, it's resistive. Why? Because the forces, let's imagine the same example with the cart, okay? But instead of a smooth floor, it's has a lot of friction. It's very rough, okay? Now, obviously, anyone with a brain can tell that this won't go as fast if it was on a smooth floor. You will push it, but that push will barely move it, like even by 1 centimeter or anything, because it's on a very rough floor. So what's happening here? The friction is pushing backwards. It's a resistive force. It's resisting the cart from moving forward. Alright? So when they ask you, it's resistive work or motive, motive basically means same direction, basically not resisting, it's helping it move. Resistive basically means the force is trying to push it back. Alright? Basically tension, friction, those type of forces, when those resistive forces, they try to push back. So that's basically means it loses energy because it wastes all its energy on trying to get through for even a small distance. But it can't since it's very rough. So that's it. Resistive, it's resisting it. Memorize it like this. Resistive resists the object from moving forwards. And motive, it goes along with the object. The force goes along with the object, okay? That's it. Now for question, okay, here we have another example. The force F acting on the box and the direction of motion of the box are in the same sense. Okay, as you can see here, they are moving in the same direction, the force and the motion of the direction of motion. In this case, the work done by F on the box is called the motive work. Like I said, when they're on the same direction, force and the direction of motion, it's motive, positive. They're moving along, the force is moving along the direction of motion. Now, by losing energy, okay, when you see losing energy, it means resistive, okay? Since, like I said, you waste all your energy on trying to get through the force that's pushing you back. So when you do that, you lose energy, right? Like, what's harder for you? Imagine this. Pushing a box, what's it called? Pushing a box along a rough floor, like for example the street outside, or pushing it along the gym floor, for example, which is smooth, or like a basketball court floor. Of course, the basketball court floor is easier because you move, it's has no friction, it's smooth, so it will be motive, it's gaining energy because you push it and it's not pushing back. But here, you're trying to push. You're trying to push the box against the rough floor. You're losing energy. You get tired. You sweat. Okay. So when you get tired, you lose energy. So that's why when you move it along the resistive floor, you lose energy. That's it. Sorry if I'm overcomplicating this. I just want you to understand the concept. I don't want you to only memorize. I want you to understand exactly what's going on. Okay? So here, opposite. These two options are opposite. Now, if you're gonna tell me why not this one, they're not moving in the same direction. So this should be resistive. No, this is different. The force here and the direction of motion, they're entirely different. So imagine you're pulling a box from this side, and there's let's say a chain holding the box, not allowing it to move. So let's say this chain is pulling the box up, and the force is pulling the box to the left. Okay, it's just gonna stop, right? So yeah, that's it. It's not resisting, nor is it going along. It's something else entirely. Now, the force F acting on the box and the direction of motion of the box are in opposite senses. Opposite, keyword opposite. Remember, motive, you see the keyword same. Resistive work, you see opposite, you know it's على طول resistive. Immediately, you know that it's resistive. So in this case, the work done by F is called a resistive work. See, the opposite directions. Now for question 15. A force F of magnitude 20 newtons is exerted in a box causing it to move along a horizontal line as shown below. The force makes an angle of 45 degrees to the horizontal. Okay. I'm gonna give you a bit of a short explanation. Imagine this as a triangle. Okay? Now, the force, which is 20 newton over here, it's pulling it from here, right? Now, they're asking for the horizontal force that makes an angle of 45 degrees with the horizontal. They're asking for this side. So you're gonna use the math rules, SOHCAHTOA, to find it, but we're not gonna do this here. I'm just explaining what's going on. How do you know if it's horizontal or vertical? Again, they're asking for horizontal, this side. So that means you do cosine, okay? Now, I want to tell you guys quickly, cosine is horizontal. and sine is vertical. Again, let me draw my own triangle. Okay, I know that's not 45 degrees, but we do 45 degrees is over here, okay? Because it's like this here, okay? 45 degrees, 20 newtons. We're trying to find this side. So we do, how do we find this side? We have the hypotenuse. So we do SOHCAHTOA. We do adjacent over hypotenuse. The adjacent, what we're trying to find, x over hypotenuse 20. Okay? So that's for cosine. You're trying to find this x. So that's just, you don't actually do this in the exam. I'm just, again, giving you a brief overview of how things work. Okay? So let me erase this. Again, cosine is horizontal and sine is vertical. Whenever you see horizontal, you know it's cosine. If it's vertical, it's sine. Okay? Now, what is the work done by the force after moving the box a horizontal distance of 10 meters? Now, the work done by the force after, okay, we're gonna do force times distance. Now, they gave us an angle, right? With the horizontal. We're gonna use this angle and I do times cosine 45. So let's apply this. Force is 20 times distance is 10 times cosine 45. Let's do this on the calculator. 20 times 10 times cosine 45. You get exactly 141.42. We put it at the integer, at the whole number. It's going to be 141 joules. Okay. Remember, work. The unit for work is joules. Okay. Work is a scalar quantity. It can be negative or positive. That's we've applied it last week and this week too. When there's a resistive force, it can be negative, right? But if it's motive, it can be positive. So that makes sense. Work does not have a direction. Okay, so that's why it's scalar. It does not have a direction. The kinetic energy of a car of mass 800 kilogram moving at 20 meters per second is equal to, okay, they want us to find the kinetic energy. What's the rule for kinetic energy, my friends? It's equal to 1 over 2 times mass, which is 800. Let me cite the rule quickly. 1 over 2 mv squared. This is the rule for kinetic energy, right? So you do this. 1 over 2 times mass, 800. Remember, mass always has to be in kilogram. Times, whenever you're doing this rule, 20 meters per second, which is the velocity, squared. Do this on the calculator. 800 times 20 squared divided by 2, you get 160,000. Okay? I want it in kilojoules though, right? This is in joules. So we divide this by 1,000. Become 1, 2, 3. So it's going to be 160. And indeed, it is 160 kilojoules. Okay. Alright, the work energy theorem states that the net work done on the body equals the change in its kinetic energy. You're gonna memorize this rule called work equals delta kinetic energy. Okay? That's basically the word theorem. That's like this sentence is basically this, but in an equation. Okay? Work is equal to the change in kinetic energy. Alright? It's always like that. A car of mass 1,600 kilogram accelerates from rest under the action of a net force of magnitude 800 Newton. The speed of the car after moving a distance of 100 meters is then equal to what meter per second? Okay, they want us to find the final velocity, right? Now, from the last theorem, we're gonna use kinetic energy, okay? But not only kinetic energy rule. Kinetic energy rule is 1 over 2 mv squared, right? We're gonna use delta kinetic energy. What's the difference? Okay, you're gonna use 1 over 2 mv squared minus 1 over 2 mu squared. Mu basically stands for the initial velocity. Okay? So kinetic energy 1 over 2 mv squared, but the change in kinetic energy, so it's changing, it's final minus initial, 1 over 2 mv squared minus 1 over 2 mu squared. Okay? Now, since we have we have work which is 1000 1 minute, we have to never mind. We have 800 newtons, the force, times the distance, which is 100, equal to 1 over 2. Again, we're using the work equals delta kinetic energy, right? We're gonna use this rule to find this. So we have to put work 800 times 100 equals half times mass 1600 times v squared, which is we're trying to find, minus 1 over 2 times 1600 times from rest. So we say 0 squared. Since it's 0 squared, it's 0 times 1600 is 0, and 0 times half, negative half is 0. So we cancel this whole thing. So we're left with 800 times 100 equals 1 over 2 times 1600 times v squared. Okay, now let's distribute. 800 times 100 is 80,000, sorry. 80,000 equals 1 over 2 times 1600 is 800. 800 times v squared is 800 v squared. Now, we're going to divide by 800. Divide by 800. We're going to get v squared equals 100. So, v is equal to 10, which is the radical. Radical of 100 is 10. That's it. And exactly, it is 10. That's the final velocity. Okay? That's for this question. Okay, a 0.2 kilogram ball is dropped from the top of a 20 meter tall building as shown below. Take gravitational acceleration equals 10 meter per second squared. Okay, what is the work done by gravity as the ball falls 20 meters towards the ground? Okay. Like I said, when you see top something from a height, immediately know it's involves the gravitational potential energy, which is mgh. Work done by gravity. Whenever you see work done by gravity, you know it's mgh. So mass 0.2 times gravitational acceleration 10 times height, which is already given 20 meters. Now we're just gonna multiply this. 0.2 times 10 is 2, so it becomes 2. 2 times 20 is 40 joules. That's the energy. And indeed it is 40. That's the work done by gravity. Okay? Now we go onwards. The work energy theorem states that the net work done on a particle is equal to the change in its kinetic energy. Like I said, the work energy theorem, remember, it's work energy theorem is work equals delta kinetic energy. The net work done on a particle is equal to the change, which delta means change. Remember, delta equals change in its kinetic energy, Ke, kinetic energy. Okay? So that's it for this rule. Now the next rule, using the expression of the work done by an object and that of Newton's second law, the expression of the derived work energy theorem is, okay, again, work equals delta kinetic energy. We write it in this form: 1 over 2 mv squared minus 1 over 2 mu squared. Okay? Initial, final. 1 over 2 mv squared final minus 1 over 2 mu squared initial. Okay? Now let's keep going. The amount of energy transferred when a force of 1 Newton is acted on a body over a distance of 1 meter is called 1 joule. Okay, I want you to put the unit. Look, J works, but to be safe, always put joule, because last week I put J and I got it wrong. So guys, when they ask you for the unit, or to put the unit, or to select which unit, or what is the unit, always put joule. Unless they ask you for the symbol. If they ask you for the symbol, you just put J. Okay? Alright, for B, Under the displacement of a constant horizontal force F of magnitude 10 newtons, a particle of mass 4 kg undergoes a displacement of 6 meters along the same direction as F. The work done by F on the particle is 60 joules. Okay.